let's start. So guys, very quickly, turn on the cameras and let's hopefully have a great evening. It is lovely outside, but it is also lovely inside if there is something to see inside, right? If it's not an empty apartment between the ears and the eyes. So guys, sine h over h, please remind me, what is this? It is 1. Thank you so much, amazing. And remind me, what is cosine h minus 1 over h? This is 0. Beautiful. And what is tangent h over h as h goes to 0, guys? All right, thank you, Alessandra. Good. It is equal to 1. Now, why is this equal to 1, guys? Let's look at 3 briefly. Limit as h goes to 0 of tangent h divided by h is what? You understand, guys? When somebody writes this limit, what do you expect is this intention of the summand? What is happening, please? Limit as h goes to 0, tangent h over h. The intention is what? Well, Sophia, sine h over cosine h is tangent h, but that's not intention. You are just cutting it in half. It's like I'm asking this. Somebody is, right? Whatever sounds it's making, right? And what you're doing, you're cutting that person in 2 parts. You're cutting his legs away from his torso. That's gruesome. What's the intention? No, nobody is canceling anyone, guys. You watch too much TV. I mean cancel culture, not sure if you didn't get my reference. No one's canceling anything. We are speaking about what is happening, guys. What is the intention? Derivative, thank you, derivative. The intention is what? Look at it, guys. This is the limit as h goes to 0 of tangent of 0 plus h minus tangent of 0 divided by h. And that's the definition of the derivative of tangent at 0. So we right away recognize that this is the derivative of tangent of x, but where x is equal to 0, which is secant squared of 0, which is 1. Do you see how I did it, guys? I do not have to go and cancel and solve anything if I know where this question is going. Instead of solving this question, I right away get to the destination by another route. If you, of course, want to do it geometrically, that's also possible. So for instance, guys, let's remember what's happening. If I take the circle, then I can see that if this is my radius, then this is sine, and this is cosine. Yes? This is sine and cosine. And where is the angle? And the angle is here. That's my angle. Yes, I'm not going to label them. I'm just going to color it like this, guys. So geometrically, where do you see tangent here, guys? Remember what we do, guys. A tangent is, as one of you mentioned, it's red divided by green. But green is not of unit length. It's not convenient to divide by it, right? So what do? We stretch the green to be equal to 1. And we consider this picture. You see? This is the line x equal to 1. Do you understand why I am interested in that particular line, guys? I'm trying to show you how you visualize things geometrically. Why that particular line? Because then I divide by 1. And I then can draw myself a similar triangle. You see, guys, a similar triangle would be extend and here is my tangent of h. Now, do you see what happens, guys? So you have that blue curve. Here is that blue curve. And that orange straight line segment. Do you see what happens as the blue curve goes down? The blue curve is like a slinky that is at its base perpendicular to the x-axis. It just doesn't have a spine to stay straight. So it curves along the arc. But as you get the angle h smaller and smaller and smaller, the blue bent out of spine curve and the orange straight perpendicular curve, they become of the same length. Do you see that geometrically? Yes? Beautiful. And that means that we can see right away from that picture that tangent h will be essentially the same as h. It means that we don't have to really use tangent too much if we don't want to. You understand, guys? When h is small, I can just imagine that the tangent is simply not there because it's not modifying the angle very much if the angle is small. Clear? So that's a very, very important insight. Now help me, guys, do the next question. The next question was, if you remember, I asked you what's limit as h is going to 0 of secant h minus 1 divided by h. What's that limit, please? Thank you, Erin. Thank you, Christian and Sarah and Alessandra. Elazar, I'm glad you're okay. I was worried about you yesterday at the end of the class, right? 0. And you, Grant, what will Grant say to that? 0. Thank you, Anaf. And Brianna. And well, that's beautiful. I hope it is 0. So the answer is that this expression, guys, forget about the, I mean, you all gave me the answer. Why is the answer 0? Could you tell me, please? And I hope you didn't do algebra. Why is the answer 0? Now, think why the answer is 0 as I let the beast out. Yes. But that's not why the answer is 0. Come on, guys, simple question. Don't fall asleep. Why have your faces fallen? I think said God to Cain, correct? Lama naflu panecha. is the same as finding the limit of tangent h, but you subtract 1 to get 0. Perhaps, but maybe simpler, guys. Why is the limit? What is happening? What is this limit getting us to? Do you understand, guys? More important than the answer is, what is somebody doing here? We just answered that question a moment ago for another function. What is somebody doing here, guys? Do you recognize it? Someone is doing what? Type in the comments. Calculating the derivative at 0. Thank you. 2 people, thank you. Derivative at 0 of what? Of which function, guys? You see, you have to recognize 2 things. If you're saying the derivative is happening, then of course it entails recognition of which function. It's very easy to recognize the derivative. Look at it, guys. If you see f x plus h minus fx divided by h, this is one of the definitions of the derivative. Do you agree? And it's very easy to identify the function that's being differentiated. Look what I'm doing. I see this function f here. And I recognize the function f by circling, let's say, usually I have the input x plus h and x, right? So the function is evaluated at the number plus the perturbation that vanishes to 0. So where do I see that perturbation? I see it over here. Do you agree? So very simply, I see that if there is a perturbation, then secant is applied. I mean, that tells me, the 1 gives me, of course, a hint of where that is applied. So I imagine right away that this is limit as h goes to 0 of secant of 0 plus h minus secant of 0, which I know is equal to 1, divided by h. Do you see? So the function I'm differentiating is secant. You all see that, guys? I'm differentiating the function secant. It's just applying the definition of the derivative to the function secant, and that gives me the derivative of secant x, where x is equal to 0, which gives me secant of 0 tangent of 0. So secant of 0 is 1, tangent of 0 is 0, and the result is 0. Good? All clear? Let's see if I modify it very slightly, would you be able to tell me what's the answer? If I say limit as h goes to 0 of secant h minus 1 divided by tangent. What's the answer? Thank you, Moshe. But the question mark indicates surprise. You shouldn't be surprised. It should be clear what the answer is. 0. Now, you see why 0, guys. What's the easiest way to think about it? What's the easiest way to think about it? Where h is approaching 0, do you agree? What does it mean? It means that tangent is receiving smaller and smaller numbers, which means that essentially it doesn't figure and doesn't do anything to the number. You understand? So I might as well imagine that this tangent vanishes. That's the quickest way to solve it. Do you see that? If I want to see it vanishing, I can say this is limit as h goes to 0, and this is secant h minus 1 over h. Same thing, because when the angle is small, tangent is not really doing anything. Yes? And the answer is then, of course, as before, 0. Another way to solve it is to use, spell check correction, which happens, of course, if there is an intention, right? When you type a word in your phone, the phone suggests which would be the word. Do you agree? So the phone tries to predict the intention. So if I were to write secant h minus 1 and root division, what would your smartphone suggest to write in the denominator? The smartphone right away suggests write what in the denominator. That's what you call wishful thinking, right? Because what you want to see there is h. Guys, if you understand that you want to see their h, you solve the problem. If you know what you want in life, you get it. That's the thing, right? So I don't get anything because I don't know what I want in life, and that's the problem. But if you know it, you will always get it for sure. And of course, it will be very terrible. So this is h, and because you don't have the h, you need to cancel it out, you see? So you put an h here. And then here, you write tangent h. And now just observe, this limit goes to 0. And this limit is 1 divided by a familiar limit. So that one will obviously go to 1. So that's just solving it another way. Of course, it's slower, right? You can just might have already just delete the tangent and you get your answer. Good. Let's see if you understand this, guys. So tell me, please, what is this limit? Thank you, Moshe. Good. Very good. Now, do you see why it's 1, guys? There are 2 ways of seeing that, which are not really 2 ways. They're the same way, right? So one thing is, what is happening? Look at it. It's tangent multiplied by 1 over x. But 1 over x is a small number, which means that tangent is not really doing anything. It disappears. Yes? So this is limit as x goes to infinity. And this is... yeah, so good that you wrote lol, because we don't cancel it. We just don't notice it. It disappears. It vanishes. Like in Back to the Future, which some of you haven't watched somehow, right? You remember that thing when he starts disappearing. You all watched Back to the Future, guys, yes? Some of you give me the impression, no, you have lost even your roots. In even American movies you don't watch that are good. Okay, so that is x times 1 over x, which is right away 1. Good? Another way, of course, is to observe that this is the same as taking tangent of 1 over x divided by 1 over x, which naturally it's just that same familiar limit, which I can write as limit where h goes to 0, tangent h divided by h, which is 1. You see what I can switch, guys. It doesn't matter how it's written. What's important is the information. We have tangent of a small angle divided by same small angle. Good? All right. Are we ready for a more challenging question? Just to see, guys, if you understand what's happening here. I would hope that if you open the book and you look at the exercises, they all will look to you like the same exercise. And how can we accomplish that? Well, let's see. Well, any page, that's the point. Any page, not just one page or another. Just you open the book and you think it's like the same page printed 1,000 times. If we achieve that, then you understood this material. Good. And then let's try to ask this particular question, guys. Could you please tell me what is this limit? Limit as x goes to infinity of the fifth root of x to the power of 5 plus x to the power of 4 minus x. Tell me what is this limit, please. All right, guys, I will wait 2 more minutes and then we will see the answer together. All right, guys. Oh, time runs so fast. What is the answer? Okay, one person says infinity. Jeffrey says it looks like infinity. Jasprit says 0. Interesting. Maybe infinity. Infinity. Okay, any other ideas? Okay, a lot of you are saying infinity. Moshe. Okay. Grant. Nicole. Dauda, what do you say? Well, let's see, guys. So you see, I'm not sure what have you, would anybody tell me what have they tried to do? So you spend this time, what did you try doing? Zapping the flies with your gaze? Simplifying, In other words, what? Algebra? You see, guys, this is what I try to, yes. So first, guys, look at it. You look at this question and you ask, why is it not immediate? Why can't I right away tell what the answer is? Yes? You see, you have this struggle, right? You can plug in large numbers if you have a calculator. You see, John, that's only because you have machines, right? So, right, a machine can solve this limit. You don't even need to plug large numbers. You have software that will tell you what the limit is. Good? So you are here and you notice that this is approaching infinity and this is minus infinity. So we have a struggle here, right? One part, the first part pushes it to infinity. The other one is trying to pull it back. Good. So what is the resolution here? So the resolution is to recognize what is happening here. So do you see that I can factor out an x to the 5 within the fifth root? So this is the fifth root of x to the 5, and that becomes 1 plus 1 over x minus x. Everybody agrees? Yes? And then do you agree, guys, that I can pull out this x to the 5? So I can write this as a limit as x goes to infinity. I pull out x to the 5 and it becomes now x. If you allow me, I will push it, I will factor this x to the 5 and factor. So that's fifth root of 1 plus 1 over x minus 1. Does this look familiar? Does it look familiar, guys? You look at this expression, do you think, oh, I've seen something like that before? And if it looks familiar, then it reminds you of what? I see. It reminds you of 0 that you might get on the exam. Yes, I suppose, right? That's of course scary. But here is what it should remind you guys of. Should remind you of limit as x goes to infinity, the fifth root 1 plus 1 over x minus 1 divided by 1 over x. I'll circle this part. It's going to 0, this part. Do you agree? So what does it remind you of now? What is going to 0? Look at it, guys. What does it remind you of? Derivative at, not at 0, Alexandra. Not at 0. So look at it. I can switch, if you prefer, switch to h going to 0. No. Limit as h goes to 0. No. Where do you see infinity? Look at it. X going to infinity, 1 over x. So it's limit as h goes to 0. The fifth root of 1 plus h minus 1 divided by h. What does it remind you of? At 1, yes, at the point 1. But what at the point 1? It reminds you of what? Guys, this is already written out. That's why we practice those formulas so many times, because you see, you had to initially find the derivative by definition. I hope you still remember how to do that. But one important reason we did that is that in nature, they will not occur at all like the definition. In other words, you have a problem, which when you convert it might at some point start to look like the definition of the derivative, which upon that, when you recognize, you can go and apply shortcuts. Yes? So this is, look at it, this is the limit as h goes to 0 of the fifth root of 1 plus h minus the fifth root of 1 divided by h. Now, do you see what the function is? This is the derivative of what function and where? What is the function, please? Well, no, I don't see a sign here. I mean, you see, don't imagine that just because we're in the section of trigonometry that it has to do with trigonometry. There is no need for trigonometry here. Guys, what's the definition of derivative? Of what derivative? Yes, of x to the 1/5 at 1. Look at it. How do I recognize the derivative? I look at this expression. Look at it. X plus h minus f of x over h. Just look at the pattern. What fits that pattern? Look at it. Let me circle the f. F is what consumes x plus h. So what is that here? That is this part. Do you agree? F is the outer thing that holds the input plus the perturbation. H is the perturbation in its belly. Yes? So the derivative is very simply, this is the same as the derivative of x to the power of 5th root at x equal to 1. You can see it here, which means this is simply, what's the derivative of x to the 5th root? It's 1 over 5 x to the power of minus 4/5, where x is 1. And the answer is 1/5. So this limit is equal to 1/5. Do you understand? Guys, you see what I'm saying? If you see this thing, then you are able to solve all those questions up to integration. And integration is just a different recognition. This book is just that idea. It's that simple. If you get this recognition, you can solve all those problems instantly. They all look the same. So tell me what is happening here, guys, just to practice this idea. If I have limit as h goes to 0, and let's say we have here, we don't even have many functions available. So I have here 3 plus h to the power of 5 minus 3 to the power of 5 divided by h. This is what? What is somebody trying to do with this limit, please? So I should see about 20 replies, guys. You should see that in 2 seconds. So far 5. Yes, very good, Elazar, very good, John. Derivative of x to the 5 at 3. Do you see how we know that, guys? It's so easy to notice it. It's because we look at the perturbation. Here is the number plus the perturbation to the power 5. So that means that we're taking the derivative of x to the 5, and the x is here at 3, right? So that's just the derivative of x to the power of 5, where x is 3. If you recognize such things, it allows you to go through a lot of things very, very fast. Good. Maybe one more. Just I don't really care about it. Just the recognition, just to recognize what sort of thing we're dealing with, guys. What if I asked you something like limit as x goes to pi of cosine x minus, well, cosine x plus 1 divided by x minus pi. What is that? Solve it as well. Dauda, I'm not sure I understand. Pi to x. So the derivative, Moshe, you're saying is 0. So you're saying the answer is 0. Yes, Moshe? Okay, cool. So if you could, guys, just spell it out. What is happening here? Why is it so easy to solve this question? Which I hope it is easy to solve. Derivative at x equals 0. Is it? Come on, guys. Come on, come on. Derivative at what? Pi. John, you're getting there. So here is the answer, guys. Look at it. What is the other definition of a derivative? If you have x and a, x minus a, limit as x goes to a. So in this case, x is going to pi. It's cosine of x, and look at it. Simply, why did I select plus 1? Because its limit as x goes to pi of cosine x minus cosine of pi. Cosine of pi is minus 1, and that makes it plus 1 here, divided by x minus pi. And so this is just the derivative of cosine x, where x is pi, which is minus sine pi, which is 0. That's it. Do you understand? It's just a matter of recognizing that this is the definition of the derivative of cosine at pi. All right, let's see what else we have. All right, guys. Could you please very quickly solve this exercise with the first question mark? I want to see cascading responses. All right, let's see. So look at it. Sine 2 theta, tangent 7 theta over 7 theta squared. What's the answer? Thank you, John. So far the answers are not cascading. I don't know why. Okay, Nicole. Thank you, Jeffrey. Jasprit, Moshe, Sarah, Brianna, and Abraham. 1, 2, 3, 4, 5, 6, 7 guys. Would be nice if more would respond. I have 23 people. Okay, Sofa. Well, what's the answer, guys? Very simple. Theta is going to 0, yes? And that means that sine of 2 theta is small, sine is not really doing anything. And tangent to 7 theta is not doing much. Do you agree? So what do I see? I just look at this expression, I see, I can ignore sine and I can ignore tangent. Yes? And instead of that, I see 2 theta times 7 theta divided by 7 theta squared. Yes? And so the answer is 2. Do you see it? Please do the next one. We're doing this one, guys. I'm waiting 2 minutes. Come on, give me a lot of answers, please. Okay, I have 5 answers. I haven't checked them yet. Let's do more. All right. And the answer is, guys, let's look at the denominator. Careful, Dauda. You see the denominator is what? The denominator is x minus 1 times x plus 2. Do you agree? So I can group together this. Sine of x minus 1 over x minus 1 as x goes to 1 will approach 1. And so what we have is 1 times 1 over x here approaches 1, 1 plus 2, and the answer is 1/3. Do you see that? So the answer for the second exercise is 1/3. Okay, next. Next, guys, is the sine of 3x over 5x cubed minus 4x, please. Thank you, Moshe. Good. This one, guys. No, that's good, Moshe. Great that you're doing fast. Do it as fast as possible, guys. Yeah, start the next one, of course. Come on, guys, this one. This one, okay? Sine of 3x over 5x cubed minus 4x, please. Okay, Ayoda, good. Good. You did well. Very good, Nicole and Sophia. Well, it's right. You don't see it. I see. Okay. Here. I just don't want to reveal the answer for the problem. I wrote it kind of, you know. All right. So how do we solve this one, guys? Simply, the easiest way to do that is simply see that if x is going to 0, sine is not going to do very much. So it's ignorable. Yes? So it's like 3x over 5x cubed minus x. So then I can cross away this x, and this is x squared. So what do we get? We get 3 over 5 times 0 squared minus 4. So that's 3 over minus 4, which is minus 3/4. You see that? You see that, guys, right? So you can do them in less than in a second. You can just look at it and you can do them. Good. So the next one is limit as x goes to pi over 4, where here we have 1 minus tangent x divided by cosine x minus sine x. Tell me, what is that limit? That's close, Moshe. You might have made a small error. That's fine. Do you guys remember how to calculate roots, by the way, speaking of which? If you had extra credit problem where I told you to calculate roots, would you be able to do that? So let's do it together, I guess. If it's much easier, guys. So what do you have here? You have here limit as x goes to pi over 4. That's okay. You're the only one, I think, that actually answered it. So limit as x goes to pi over 4, and that's 1 minus sine x over cosine x. Yes, since we see those guys in the denominator, why not do that? Now look at it, guys. Here they are one over another, and here they are next to each other. So let's multiply by cosine both sides. You agree? So I'm going to multiply this by cosine x, and to balance the equation, I multiply denominator by cosine x. Yeah. So what do I have in the numerator? In the numerator, I have cosine x minus sine x. And in the denominator, I have, I probably wrote it, Moshe. I think the way I wrote it, it's not the way the exercise was written in my notes. That's why you are actually right. So it's then cosine minus sine x times, and then the denominator is just 1 over cosine x. This is just 1, and this is 1 over cosine x is secant. So that is root of 2, and you're correct. The reason I thought minus root of 2 is because in my notes it's written sine minus cosine, so it was my mistake. Good. Sine x minus cosine x. Really, in my notes I wrote the reciprocal of it, so it ends up being minus root 2. All right, guys, are you ready for the next one? Tell me, please, guys, remind me, first of all, what is this limit? Limit as h goes to 0 of 1 plus h to the power of 1 over h. This limit is equal to what? You remember? Do you know? Better than remember. Do you know what this limit is? Okay, Nicole says this limit is equal to 1. Do you agree with Nicole? Okay. Erin says it's E. Sophia says root. Root of what? Moshe says E. Okay, Jasprit says E. Yes, it is indeed equal to E. Guys, do you remember? Let's just take a moment, a segue to recall why the answer is E. Okay, you have to play with your derivative. Look at it. We have f of x equal to e to the x, right? Then we know that f of 0 is equal to 1. And we know that the derivative of x is equal to the function itself. Derivative is not changing the function, yes? That means that if I set the limit where h goes to 0 of f of x plus h minus f of x divided by h, what will I get? What do I write across the equal sign, please? Type in my comments. What is here? Limit as h goes to 0, f of x plus h minus f of x over h. What do I write here? Yes, e to the x or f of x, because look at it, the derivative is equal to that. So I'm just expanding it. And I can say this is my f of x, okay? Which, guys, it means that if I drop the limit, it means x plus h minus f of x is essentially the same thing as h f of x. Do you agree? When h is very small. It's a pretty difficult idea, but that's what we're trying to accomplish, guys. Remember that even if you're not trying to accomplish that, the exam is conceptual. So what do we have here? So we see that f of x plus h is approximately equal to 1 plus h times f of x. It means that the function at a number is approximately equal to take one step back, 1 plus that step back times the number minus the step back. Do you see why this last statement is true? You see, it's just an interpretation again, guys, right? So that means that the function f of x is approximately 1 plus h times f of x minus h. Do you see that? Don't focus on x and whatnot. What is it saying, guys? It says that the function at a number is equal to a number to the function at the number at the prior step multiplied by that step, right? 1 plus that step. Do you see that? It's just what the equation is telling you. So don't focus on the letters. They are just trying to communicate the meaning. The meaning is that you can walk back. You see, to evaluate e to the x, you can always walk back. And when you're walking back, you multiply by 1 plus h each step you take. Where are you trying to get, guys? You're walking back to familiar territory. To what number do you try to go back? Type in the comments. You understand this is recursion, right? So I want to know what is the function at x. Instead of figuring what's the function at x, I step back and I say the function at the previous step. Multiply that by 1 plus the step. That's still hard, so I will walk back and I multiply again by 1 plus the step. I do that until I get to which step? Where do I want to be? Where is my home? Well, depends on where you look at it. So on the x-axis, my home is at 0. Yes? The answer will be 1 at 0. Guys, what are we trying to do? You have to kind of have a sense of it. Otherwise, look at it. You see? At 0, it's 1. I know the value at 0, so I don't know it at any other point. So I walk back. Good? So then I walk back. Let's try to understand how that's supposed to help me. Look at it. Here is 0, and here is the point x. Divide into tiny steps. I draw them, but they're really tiny steps. So you see, guys, so from here to here, to here, to here, to here, to here, to here, I just will walk back all the way to 0. Now, what's the size of that step? The size of that step is x divided by n, where n is huge. Because if n is huge, x divided by n will be small, and that justifies taking those steps. Yes? Do you see what's happening, guys? So that means what is f of x? F of x is 1 plus x over n f of x minus x over n. This is, I still don't know. So that is 1 plus x over n. I take another step. So I write the square f of x minus 2x over n. And continuing in this fashion, I eventually reach 0 after n steps. So that's 1 plus x divided by n to the power of n, f of x minus n x over n. I took n steps back, and that's simply, this is simply 0. And at 0, the function is 1. So the result is 1 plus x over n to the power of n. Do you follow? So that means that e to the x, guys, is equal to limit as n goes to infinity, because the more steps I take, the smaller they are, and the more accurate is this approximation. Limit as n goes to infinity of 1 plus x divided by n raised to the power of n. Okay, now I can write it in another form. Look at it. This is e to the x, limit as n goes to infinity. I can write it as 1 plus x, and here I have 1 over n. To the power of, what is, so to the power of 1 divided by 1 over n. Now look at it. This is a small number. This is a small number, which means what I see is that I can also write it as limit where h, where the number goes to 0, number is getting smaller and smaller, of 1 plus x times h to the power of 1 divided by h. Do you see that? It's just a reinterpretation of that previous result that I can just right away see the answer. You see that? We're going to derive it again and again, guys. And the point, I'll show you the point if you are not going to collapse, of course, from Because if you do anything in physics, simple questions in physics will involve those manipulations already as a very last step. You understand? You will have limits that will, if you can set it up, you already probably can solve them. So the problem is really setting up to realize what is this problem mathematically. So this is e to the x. So in our, of course, then e to the power of 1 is simply limit as h goes to 0 of 1 plus h to the power of 1 over h. Now with this information, please tell me what is limit as theta goes to 0 of 1 plus sine theta to the power of 1 over theta. What's that? Very good, it's E. Thank you, Moshe. Amazing. The answer is simply that I can ignore sine, and this is limit where theta goes to 0 of 1 plus theta to the power of 1 over theta, which is E. So guys, what about next? Do you want a challenging question or a very challenging question? Both, yes. Good answer. But there is a question mark. Let's see if I want to kill you right away or... All right, so let's drag it a little bit, even though I don't like dragging. Right? So tell me, guys, first, this is just limit as x goes to 0 of e to the tangent x minus 1 divided by x. Tell me what is this limit. That's not the challenging question. I'm just still dragging it. Good. Very good, Moshe. And John, amazing. Ayodel, very nice. So we have 4 people that answered. Brianna. Right, it's very clear what's happening here, yes? It's simply a limit where x goes to 0 of e to the x, I can ignore tangent, minus e to the 0 divided by x minus 0, which is the definition of derivative of e to the x, where x is 0, so that's e to the 0, which is 1. Yes? Will that be challenging? I don't think it's the challenging question, actually, right? So, but what if I ask you a limit where v goes to 0 of 1 plus tangent of 6v to the power of 1 over sine of 2v? Would you be able to tell me what this limit is? Okay, maybe it doesn't exist. That's what Moshe thinks. John says 7 over 2. Sophia says 3. Seven over 2. It's not a product. Maybe that's what confuses you guys. This is to the power. Maybe that's why you're saying 7 over 2 and whatnot, okay? To the power. Okay, Aaron, interesting. Square root of 7, John. Okay. Ayodel, interesting. Ready? So the answer is very simple, guys. Same thing we're doing. Look at it. Ignore the tangent. Simplest way is to ignore tangent, ignore sine, because v is small, 6v is small. So that's 1 plus 6v. And here I have 1 over 2v, which is what? This is the limit as v goes to 0, 1 plus 6v to the power of 1 over v to the power of 1/2, yes? And what is what we have? What do we have here? This limit is simply e to the 6. So it's e to the 6 to the power of 1/2, which is e to the 3. Was it difficult? It wasn't, yes? Because we're using, again, guys, why not difficult? Because we're using the same idea, right? We're saying angle goes close to 0, then sine of it is not changing the angle. Is this Euler's formula? Well, I'm not sure which specific Euler's formula do you refer to. There is something that, of course, since you are talking about it, we would like to define. Perhaps you're ready for the challenge then, right? Since you're speaking of Euler's formula. Let's see. Let's see if we are ready, guys. You see, it's so amazing. And the rest of them are very similar. Yes, guys? So for instance, can you tell me what's the limit with a question mark? The first question mark is what? Fast, guys. This should take you like one click right away, and you have it. Well, actually, it should not. Right. It should not. Well, my apologies, right? So this particular question is the limit is jumping around. So it's the limit is not defined. I probably meant 4 over x. I'm presuming, right? So I don't know what might I have met. But if the question is x times tangent of 4 over x, the answer is going to approach, if this is the question in red, the answer is going to approach what? No, it's not going to approach 0. 4. Because tangent 4 over x approaches 0. And tangent is not doing not bothering with things that are small. So that is x times 4 over x, which will approach 4. Yes? Could you quickly answer the second question mark, please? Second question mark, I hope it will take you 2 seconds. Okay, Sophia's one small mistake. And Odell, that's right. Yes, it's e to the 1 over 5. Very quick. You agree, guys? No need to re-explain, correct? It's just very quick. E to the 1 over 5. Because you just see, you ignore sine, you ignore tangent, and that's the quickest. You can actually do it another way if you like, but that's the quickest way to realize the answer. Yes, and tangent and sine, the angle is going to be small. Tangent and sine are not doing anything really, and that's easy question. Good. Now tell me, what's this other question mark here, guys? The last question mark, please. Well, this is not the last, this one. What's the answer? Ayodel, amazing. The same for Moshe. Come on, Sophia, great. Brianna. Enough, very good. I hope, guys, that you are not just looking into the messages and copying the first answer I say is good. But if it's from then it's pretty amazing. It's great. So this exercise, well, it's very simple. It's the derivative of tangent. Do you agree? The derivative of tangent at pi over 4. So you'll see that tangent of pi over 4 is 1. So this should look to you like, very quickly, the derivative of tangent of x, where x is pi over 4. And that's simply secant squared pi over 4, which is 2. It looks to you like this, yes, guys? I do not need to re-explain anything. It does look the same, yes? It's the sign just disappears. It's the definition of the derivative. Just slightly invisible. Now cosine z over z minus pi over 2 as z goes to pi over 2. This one. Please quickly tell me what's the answer. Cosine z over z minus pi over 2, z goes to pi over 2. What's this limit? In the numerator, it's, let me write it. If you it's not a 0, of course, it's just a scratch. It's just a scratch, guys. Obviously it's a scratch. So it's cosine of z over z minus pi over 2. What's the limit as z goes to pi over 2? Ayodel, that's exactly right. It's -1. You'll see why, guys. This is the definition of the derivative of cosine x, where x is pi over 2, which is minus sine of pi over 2, which is -1. So the answer is right away -1. Easy, yes? Ready for your challenge question? If you want it, of course. If you choose to accept one challenge question. You understand, guys, that the angle, well, let's see if you understand. So when I take limit as h goes to 0 of sine h over h, and I say the answer is 1, the angle is measured in what? The angle of sine. It's what? When I say sine h over h is 1, the angle is radians. Yes? So basically, when I say that the derivative of sine x is cosine x, guys, I of course mean that that we are measuring x in radians. You agree? When we do that, we measure in radians. So here is the challenging question, guys. What is the derivative with respect to x of sine of x degrees? If I take the derivative in degrees, what would the derivative formula be? Let me give you a very good hint. Tell me what is limit as h goes to 0 of sine of h degrees divided by h. You see, guys, we have that the derivative of sine is cosine. We are using radian measure. If we don't use radian measure, but use degree measure, perhaps the derivative formula will be different. So the derivative you're saying is 0. So this limit is 0. All right, other ideas? What's the simplest way to do that, guys? Convert it to the situation where you know how to deal with, right? So its h is degrees. So sine of h degrees divided by h. Now, why would it be a 6? It's degrees here. So it's this. And the answer is what? Yes. So look what happens. Look at this limit, guys. The limit is, what is h degrees? So we know that 1 degree corresponds to pi divided by 180. So h degrees corresponds to pi over 180 times h radians. So this is the same as the limit where h goes to 0 of sine of pi over 180 h over h. And the answer is pi over 180. So this limit is pi over 180. Good? Wonderful. So do you remember how to calculate e to the x, guys? E to the x, how do you actually calculate what is e to the x equal to? Let's say I want to know what is e squared. You can say you press it in your calculator, but what is your calculator doing? How do you calculate e to the x, please? Remind me. You see, those derivatives are actually what powers your, yes, they power your computer. How is your computer knowing what to do? The computer is multiplying. No, it's not going to do that at all. Here is the situation, guys. Remember, you forgot entirely what it is. So if e to the x is a polynomial, because that's a0 plus a1x plus a2x squared plus a3x cubed. This is very easy to carry this calculation. Yes? Thank you, Erin. Do you see that, guys? So what are those coefficients? How do I find a0? How do I find what is a0? Remind me, please. You have to understand, guys, calculus is building up out of Lego this complicated function or other complicated things. So polynomials are simple. We are building e to the x out of those polynomials. What is a0? Easiest way to obtain it is we know that 1 is equal to e to the 0, yes? So that gives me a0 is 1. What is can you tell me what is A1, guys? What do you do to obtain A1? Remind me, what do you do to get A1? You see, so I do what? What is X, Journal? I'm not sure I understand. How do I get A1 here? Yes, but why? How do I get, well, Sophia, I'm not sure if I understood what you wrote, but why, how do I get A1? Let's say this, A1. Nothing could be simpler, guys. Think about it. The derivative of e to the x is e to the x. But if I take derivative of the other side, I get a1 plus 2a2x plus 3a3x squared onwards. Plug in 0, so I get 1 equals to e to the 0 equals to a1. Do you see that? Very easy idea, guys. Polynomials are easy to differentiate, are easy to manipulate this way. And e to the x is easy to differentiate. Now, how do I get a2? I take another derivative, and I get that e to the x, because e to the x doesn't change under derivatives, is equal to 2a2 plus 3 times 2 times a3 x and onwards. So what do you get? I get 1 is equal to e to the 0, which equals to 2a2, which means 1/2 equals to a2. Do you understand what we just were recovering, guys? We're seeing that e to the x. We're seeing that e to the x is equal to 1 plus 1 plus x plus 1 times x plus 1/2 times x squared and onwards. How do I get the general term? How do I get the term a sub n? Well, think about it, guys. I want a sub n to be without any x's. Do you agree? I want it to be without any x's. So it's a n x to the n. And I'm going to push the derivative, and it will be n a n x to the n minus 1. And then I'm going to push the derivative, and it's going to be n minus 1 a n x to the n minus 2, all the way until I see n factorial a sub n, and then there is no x. It's going to be x to the power of 0. Do you see that? Do you see the n factorial in front of a sub n? Yes? And so what are you getting, guys? This is when I plug 0 into e, it's just still, when I take the derivative, it's e to the x, it's e to the x. So we have 1 is equal to e to the 0, which is equal to n factorial a n. Are you with me? Which means that a sub n is simply equal to 1 over n factorial. I figured out all coefficients simultaneously. It's very easy to do if you understood derivatives. So that means that what is e to the x? It's just 1 plus x plus 1/2 x squared plus 1 over 3 factorial x cubed, and so on. Right, so then if I want to calculate e squared, I just write 1 plus 2 plus 1/2 times 2 squared plus 1 over 6 times 2 cubed, and onwards. When you make the machine, you can actually figure the precision. You don't need to add all the terms. There are infinitely many terms. You just add a bunch of them, and you can calculate how precise is your approximation. Do you understand? Now, this is a challenge that I'm not sure if you will pick it up, but try, guys. Same idea. Can you figure out what to do with sine x, how to calculate? Do you understand? And for cosine, right? Always think, how can I use calculus to figure out how to calculate? How can I use calculus to calculate roots? How can I use calculus to calculate sine and cosine? It's very useful for such things. You understand? How do you design the engine? What is the machinery by which sine is digesting x? We just had geometry before and we only knew a few values, but your calculator is able to just give it an angle and it's able to compute that angle. So by looking through it, you get both theoretical and practical fruits, so to speak. All right, guys. So so for today, I suppose we're done. That's up to you. I mean, try to calculate it if you want to see something amazing. Try to see if you understand the idea here. Can you figure out what those things are without looking anywhere?